Hey class, and welcome to part 4 of lighting. This lecture will be discussing lighting power density. So lighting power density, the key to focus on is power. It's less about the quality of light and much more about the amount of power that we are using to generate that light. So think of electrical bills. Lighting power density is measured in terms of watts per square foot. That are used specifically for lighting. So there's a few ways to go about measuring the lighting power density in a manufacturing facility or an office. First up is to simply identify what fixtures are in the office. So I'm in an office right now. Let me see if I can tilt my camera up. Um, you can see there's some fluorescent light bulbs up above and some well lights as well. And inside those are some compact fluorescents. So you can, here, let me just pause for a minute and get you guys a closer. All right, so here is an up-close view of that fluorescent light fixture we were looking at earlier. I took the liberty of popping the cover off the other side, and you can see there that it is a very skinny bulb. It is a T5 bulb, and if you look on the very end, you can actually see the wattages. This one is a 28 watt bulb. All right, now that you've seen that, let me pause again. So that's something that you may have to do time to time in building audits because it's tough to tell exactly how many bulbs are in each fixture, and oftentimes they're obscured by some sort of cover like this to diffuse the light, but you actually need to count up the number of bulbs and figure out the wattage on each one of those. All right, so first, identifying fixture types, and sometimes you might not always have a ladder or access to view the actual wattages, so you might have to make some estimates. What are some reasonable numbers to make? So for like a 4-foot fluorescent tube, T12, these are the really old, thick ones. Those are 40 watts generally per bulb. A 4-foot T8 is at 30 watts. The T5 we were just looking at, that was at 28 watts. So there's a range, but somewhere in there. An LED T8 replacement, which might look the same until you actually take the full cover off, might be at 18 watts. A halogen bulb, this would be like in those well lights. Looks like the ones in this room were already replaced by compact fluorescents. A halogen bulb would be about 75 watts. An LED replacement for that would be all the way down at 15 watts. And then a high intensity discharge or high pressure sodium, HID, HPS. These would be your big manufacturing facility, bright lights. Those might be at about 400 watts. And an LED replacement for one of those might be in the 150 watt, 140 watt range. So those are rough figures. If you are going through and you can see the fixtures, but you can't actually get close enough to the bulb, or you don't have a spec sheet on the floor plans. So keep those numbers in mind, maybe jot them down for future reference. All right, so the first part, adding up all the watts. Second part, you need to figure out the square footage, right? Lighting power density, watts per square foot. So in terms of square footage, you can measure that with a tape measure. It's a pretty onerous task, but possible. Ideally, I like to get a set of floor plans, either a CAD file, or I take images with my phone of the actual original plans or blueprints. If you're looking at the architectural set, you'll get usually a cleaner view of the different rooms, and oftentimes the square footage will be included. It's also helpful to have access to the electrical plans, which does include each of the lighting fixtures, and you can see if there are any daylighting zones, which might have different controls from the rest of the facility. One of the downsides of an electrical lighting plan, well, normally this is great, and you can just count it all up on the paper. These fixtures get changed over time, and the plans might not necessarily be up to date. So you might have to do a double check just to make sure. All right, so the process of calculating is pretty simple. It's just adding and dividing. So you add up all the fixtures in the space, divide by the area. And you can do that for each individual space, each office, each warehouse zone, or you can add up the entire building's interior lighting and then divide it by the interior square footage. In the energy code, you can look at building-wide lighting power density or specific room lighting power density. Generally, these are less than 1. Now, they can be much lower depending on the actual facility type and if they're using LED or high-efficiency fixtures. But in Office now, for a new office, according to IECC 2015 code, you can have a lighting power density of 0.82 watts per square foot used exclusively for lighting. Now, that's excluding emergency lighting, exit signs, things like that, just your interior office lights. Exterior, you might have some accent lighting on the building, maybe some security lighting, and some parking lot lighting. Those are considered separately, so don't add those into your interior lighting power density calculations. The way you add these up is a little bit differently. I mean, you're still adding up the watts, but sometimes the allowance is given per linear foot. Depending on if it's like a walkway, it's looking at the perimeter of the building. Same with entries. Parking lots, those are a little bit easier. You can look at the square footage of the parking lot and add up all the parking lot lights in terms of wattage, divide that by the square foot. So parking lots, very low wattage per square foot, right? We don't want many fixtures in parking lots because it's just enough to get us to our cars. You're also allowed generally just an extra 500 watt buffer in addition to this watt per square foot in terms of code. All right, so that's measuring lighting power density. Let's talk about reducing it. So if you are tasked with, you realize that the lighting power density is way too high, say it's like 1.5 for an office building, and you're like, let's reduce that. One might be as simple as delamping. So if you have a whole bunch of fluorescent fixtures, but you don't need both bulbs in there, you're still getting enough brightness. We'll talk about measuring illuminance in the next section. If you're getting adequate illumination on the surfaces in the space, you might be able to just turn off a couple of lights and take bulbs out of the fixtures. Some of these fixtures contain, 4 different bulbs, and they might just need 2 of them. So that's one cheap, very easy way of going about it. The other is to upgrade your lights. And by upgrading, you still want to add the same number of lumens, but do so using fewer watts. So adding lights that are of higher efficacy or higher lumens per watt. So for one example, let's look at, say, a parking garage. You have one fixture in there and you need to provide 10,000 lumens of output. You could use an LED, and that has an efficacy of 100 lumens per watt for 100. So you're getting 10,000 lumens out of both of these bulbs. The LED is going to draw 100 watts. A high intensity discharge, or maybe one of those high pressure sodium lights, that has a lower efficacy of 66 lumens per watt. So for the same 10,000 lumens, you are using 150 watts. In terms of financial savings, let's assume that these are on at night, so about half the year. A year's a little over 8,700 hours, so I'm just assuming 4,000 hours, nice round number. And since we're getting the same lumens, but we're using fewer watts to do so, we save 50 watts per fixture. So watts times hours per year, that's 200 kilowatt hours that we're saving per fixture. Assuming a generic price of 10 cents a kilowatt hour, multiply your kilowatt hours times your kilowatt hour price, and you end up with an estimate of saving $20 per fixture per year. So that's part of the life cycle cost. The other part is, of course, bulb life, and we'll talk about that a little bit in the next lecture. And the other piece is, of course, how often those lights need to be replaced. So not only do you have to buy a new bulb, but you might have to hire your maintenance staff or bring in a cherry picker or high crane if it's in like a warehouse environment to access some of those high lights. And so a longer light lifespan can be extremely helpful. All right, so quick review on this. Lighting power density, LPD, you measure that in terms of watts per square foot. A good lighting power density is generally less than 1. You don't include exterior lighting in that. Those are counted separately. You can reduce lighting power density by delamping if it's appropriate, if you still have enough illumination in the space, or by upgrading to lighting fixtures with a higher efficacy or more lumens per watt. Thanks, and see you next lecture.